I used to have to like frame up my hair in the shot. I don't have to worry about that anymore. So I know a lot of you are stuck inside right now, and depending on your living situation, how many people are living there with you, how big your house or apartment might be, if you're storing a whole bunch of food or toilet paper or whatnot, you might be running out of space. But as PC enthusiasts, what do we always want to do? We want to game and we want to build new systems. So that's what we're going to do today. We're taking a mini ITX approach. We're going to take up as little room in your house as possible while still being able to play the newest titles. This is what we got going on today. Let's put it together. Introducing the ShadowRock 3, the newest product from cooling specialist Be Quiet. If you're looking to keep your CPU thermals in check while also running virtually silent, the ShadowRock has you covered. Featuring 5 direct contact copper heat pipes and an offset cold plate design, the ShadowRock provides maximum memory clearance for even the tallest DIMMs. It also looks stylish inside your tower due to the brushed aluminum top plate and black and silver color neutral aesthetic. Check out the link below to learn more or head to bequiet.com. Let's run down a parts list first, starting with our case. This is Fractal Design's new Era ITX, and as you can clearly see, it's a pretty stark contrast to the products they've been putting out over the last couple of years. For starters, first of all, it's tiny. Secondly, it's made entirely of aluminum, and it has a walnut top. Obviously, it's removable. You can put a mesh top up here instead. But the overall design language, the aesthetics, the curves, it looks totally different from any other Fractal case that I have ever seen. Now, reviewers that have had their hands on this for a while have figured out that this case does have some thermal challenges. And as a result, I've tried my best to tailor our hardware to fit those challenges and to meet those requirements. I don't know necessarily if it's going to work. We're going to test temperatures later, but I really did want to do a build in this case because it is definitely intriguing and it's something completely different. Let's talk a little bit about how I'm going to try to overcome those thermal limitations. The first thing that I thought of when watching other reviews of this case is that a lot of reviewers were reporting GPU temperatures that were just kind of out of control. And with a small enclosure, the way you overcome that is by trying to eject as much of that hot air as possible instead of recirculating it inside of such a tight space. And you do that with a blower cooler. So this is the 5700 XT. It's AMD's reference design. It uses a blower cooler. You haven't probably seen it very much on my channel, maybe even in a lot of other channels since launch, because there are other better 5700 XTs on the market. Cards that have better coolers, bigger heat sinks, bigger fans that run slower and are quieter. However, in this case, this card is probably going to do a lot better job inside of an enclosure like this, just because it's not recirculating all of that hot air inside of such a small space. It's actually going to eject it out of the back of the case. The second way is by trying to brute force some airflow up through the top. Now, initially when I do my evaluation of this system build, I want to leave the wood top in place because I think it really looks cool. Inevitably, I think we're probably going to have to switch to the mesh top because we're going to put a Fractal Celsius S24 in here. This is a 240 millimeter AIO. We're going to mount it to the top with the 2 fans pointing out as exhaust again. So hopefully we're able to push a lot of air up and out of the case, a lot of that hot air generated by all the components inside. And I hope that the S24 is going to be enough to keep our CPU cool in that situation. Like I said at first, I do want to try it with the wood on top, but we'll probably switch to the mesh at some point. The CPU that we're going to be trying to keep cool is the i7-9700K. Yes, this is an Intel-based system. We haven't done one of those in a long time, and I figured it was about time to take a look back because inherently these are not bad chips and they're great for gaming. They're just priced in a little weird spot right now, considering that AMD is just kind of crushing it with Ryzen 3. So we are going to go back, we're going to check out the 9700K with the 5700 XT, and we're going to put it in a Gigabyte Z390i Aorus Pro something? Yeah, Z390i Aorus Pro Wi-Fi. I've used this board, I think, once before in a build. It's an excellent high-end Z390 board. It's got all the features that you want. It looks pretty cool too, but that honestly is not going to matter because we don't have a clear side panel here. For memory, we're using a 2x8 gig kit of Patriot Viper Steel. This is a 3600 speed kit. It's going to do us just fine for this build. It's got no RGB on it, but again, that doesn't really matter. As you can see, actually, there's kind of a theme. There's no RGB on any of these components, which is something that we don't often do on this channel, so kind of refreshing. For power, we're going with Corsair's SF750. Now, this is probably a little bit overkill as far as wattage for this build. However, I don't have their SF650 in office. We're just going to use the 750 instead. This is an SFX power supply, which means it's tiny. It's going to give us a little bit more room to build in because the Era actually can be built with a standard ATX power supply if you want. However, then it does restrict the space for the GPU inside. So didn't want to do that. We're going to go with the SFX power supply, the SF750 from Corsair. It has the appropriately sized cables for an SFX type build. They're individually sleeved if that matters to you. Should be plenty of power for us. And for storage, we're just using one drive. This is the WD Black SN750. It's an NVMe SSD from Western Digital. Read speeds of about 3,400 megabytes per second, so it's super fast. It's not Gen 4, but again, we're building with Intel, so that doesn't matter. And as I always encourage people to do, pick the storage option that makes more sense, the most sense for you and what you plan on putting on your system. Don't just take storage from me. This is just what we're using for this build in particular. And I think for this build, it's gonna do great. So let's get it together, let's test it out, and let's see how it performs. So guys, we just finished the build. As you could probably tell, there's still stuff all over my table here. But just wanted to do a quick overview of the build process and how this case deals with a build like this. So as we knew kind of going in, cable management room is really not that plentiful here. You have like a little bit of room under here and maybe a tiny bit of room at the end of the graphics card to stuff cables. There's really no cable management room behind the tray at all. I was able to put behind there just like one or two very, very small like fan cables and something like that. But other than that, you cannot fit a full-size like 24 pin or even an EPS cable back there. There's just not enough gap clearance between the motherboard tray and the closure of the back panel. So basically all your cables have to go in here, and this was kind of the best that I could do. This cable is a little bit longer than normal on this power supply for an SFX unit, but I mean, I'd rather have it be long than too short and not be able to reach, especially considering we're doing a build where we don't have a clear side panel. One of the things that I did notice though is that spacing for AIO tubing is not great. So if I turn this, you can see that it sticks out, right? So this is going to be, I mean, I've closed this. It does close because I could kind of take these and kind of push them up here a little bit. I don't know, here. If I could push them like that, and that fits within the side panel, but again, just kind of barely. And this is a fractal AIO, so you'd think that they would build this case with enough clearance for their own cooler. I did try flipping this around, putting the tubing over here, but the inlet and outlet would not work with this spacing where the power supply is. I did try moving this down as far as I could, and it didn't do anything. I still couldn't fit this because this requires, in order to make a turn, it needs like that much room, and there was no way I was getting that in there. So in any event, the input and output of the radiator does have to go over here, and then you end up with extra tubing. So that is a little unfortunate. Let's get to doing some testing with this system now that it is all set up. The build process in here was pretty normal for a mini ITX system, but the last mini ITX system I built, I just came off of the NZXT H1 review, and that system, from taking it out of the box to having a system fully functional and up and running and pressing the power button, was like literally 15 minutes. So going back to something like this, where you were dealing with cramped spaces and not a lot of options, and having to remove some panels to get to some stuff, yeah, granted, this gives you some more storage options, but at the same time, it makes the build process take a little longer. And this was a more, I don't know, familiar mini ITX build, and it took maybe an hour and a half, something like that. A little bit longer with having to move the camera around and set up for different shots. So in any event, here is our system. It looks okay, and we're gonna see how it performs now. Still not used to this. So our build is complete, our testing is done, and our results are in. And unfortunately, I do have to report that initial reviews of this case did not exaggerate the thermal and airflow deficiencies of this design. I experienced a lot of what other reviewers were seeing in CPU and GPU thermals that were far worse than we would expect under normal circumstances. That does have a lot to do with airflow gap spacing. There's not a lot of room down here for air to enter, and every other place in the case is pretty much closed off. There's a little ventilation on the side panel, but not a whole lot. Generally, this case is trying to promote bottom to top airflow, and it's just not working. The GPU just blocks off all of that air. I think if you had a system build in here that was an APU, didn't use a GPU, and you had two fans at the bottom blowing up, you might be able to achieve some good temperatures, but let's be honest, that's not how most people build their systems. I did flip the rear fan around to be intake to try to introduce maybe a little bit of fresh air, and it didn't really work. With the wood top panel in place and my torture test running, which is basically I loop both Unigine Heaven and Cinebench until temperatures normalize. So this is like a worst case scenario, so do keep that in mind, but it's not out of the realm of possibility for somebody to put a stress like this on this kind of a system. But in any event, with the wood top on, the CPU hit 86C and the GPU hit 91C. Both of those extremely toasty, and while Intel CPUs can function at higher temperatures, we certainly wouldn't want them to stay that way long term. It was boosting up appropriately and staying at that max boost, but there was no overclock applied at all. And as a result of the high GPU thermals, our 5700 XT was clocking down fairly significantly. We did alleviate a little bit of that problem, or actually quite a bit of that problem, by switching to the mesh top panel. That brought CPU temps down to 73C and GPU temps down to 84C, so much more within the realm of acceptability, but still a little bit higher than we would want. And we did have to lose a lot of the aesthetic value of this case in order to get our system under control thermally. So that's a little bit unfortunate, because the big selling point of this case is that it looks gorgeous, especially with the wood on top, and unfortunately I don't think that that's really a practical solution. As a result of those temperatures, unfortunately, it's also a very loud system. Yes, we were using a blower cooler on our GPU, but basically every fan in this system just ramped up as high as it would go as soon as I put any kind of a load on here, because otherwise the components would just not get enough cooling capacity. So sitting next to this thing while running my tests, it was not a pleasant experience, and this is not something you want to have on your desk that way. It wouldn't be conducive to any other kind of work. Yeah, people use the excuse like, oh, I'll just use headphones, but I mean, are you always wearing headphones? Because if you're not gonna want to sit next to this thing. Performance though was pretty good. I did run all of my testing at 1440p. and ultra settings. So we tested 7 different games: Metro Exodus, Shadow of the Tomb Raider, Far Cry, New Dawn, and Wildlands. You could see on the screen right now for those results. I also did test Strange Brigade, which was 121 frames per second, Assassin's Creed Odyssey at 56 frames per second average, and I also ran some Doom Eternal, which I was really pleased with the results of. The gameplay that I captured there was between 160 and 180 frames per second. In other parts of the game, it was maybe a little bit lower, maybe 130, 140 frames per second. We were still well above that 60 FPS target and above 100 frames per second, coming into the realm of that 144 hertz real sweet spot for a game like this. So I think that this kind of a system, this build itself for Doom Eternal is great. Especially at a resolution like 1440p, but I probably wouldn't build it in this case because, again, not great thermals, not great acoustics. So sorry, Fractal, I do like this design, I don't like the results, and unfortunately I wouldn't recommend that people do a build like this in this case. So that is a wrap on this build. We will be back next week with another build. We're going to be doing builds almost exclusively from here on out on the channel because I know that that's what you guys want to see. We're going to test some components in conjunction with each other in real world scenarios, not on a test bench. We're going to get some gaming results to you so you can see what kind of hardware you might want to buy for the resolution that you want to game at. So make sure to get subscribed if you want to see that and you don't miss any of that upcoming content. Thank you so much for watching this video today, guys. I hope you enjoyed it. Hit that like button if you did, and I will see you next time.